In this video, I'm going to take a look at a three-dimensional trigonometry problem. Romeo is serenading Juliet while she is on her balcony. Romeo is facing north and sees Juliet at an angle of elevation of 20 degrees. Paris, Juliet's other suitor, is observing the situation and is facing west. Paris sees the balcony at an angle of elevation of 18 degrees. Romeo and Paris are 100 meters apart, as shown in the diagram. Determine the height of Juliet's balcony above the ground to the nearest meter. So let's look at this situation more closely. So we have Romeo standing here. He sees Juliet at an angle of elevation of 20 degrees, and he's facing north. 100 meters away from Romeo, we have Paris. Paris sees Juliet at an angle of elevation of 18 degrees, and Paris is facing west. Okay, and we have Juliet right here on the balcony, and she's a certain height above the ground. So, when looking at what we have here, it seems like we don't have enough given to us because we only have this angle, so an angle of 20 for this triangle, and we have an angle of 18 for this triangle. And for the third triangle here on the base, all we know is one side, which is 100 meters. Now, these triangles are all right angle triangles. And the reason for that is because they all have sides that are perpendicular to something. So, for example, this triangle here on the right, this side is perpendicular to the height. Okay, so that means that this angle here is going to be 90 degrees. So let's draw that in. Select the color. So this would be 90. And similarly, this would also be 90. And because Romeo is facing north and Paris is facing west, then this angle here is also 90 degrees. Okay, so we have three right angle triangles. So for a problem like this, you would think that you would need to use sine law and cosine law, but actually you don't have to use it, because we just don't have enough information in order to use sine law and cosine law. So what we're going to start with is we're going to write an expression for the left triangle. So what we're going to write is we're going to write a tangent ratio for the left triangle. So tan of 20 is going to equal the height divided by the side length. So the side length, I'm going to assign r to it. Okay, so this length here, the length that Romeo is away from, I think it's a tower. So Juliet was in a tower. There was a balcony in that tower, or let's just assume that it's a tower. It could be any building really. So this distance here, the length of the base of this triangle is r, and we'll assign lowercase p to represent the length of this triangle here. Okay, So that's the distance that Paris is from this point. So going back to this expression, so tan 20 degrees is going to equal h over r, and tan of 18 degrees is going to equal h over p. Okay, so remember that the tan ratio is opposite over adjacent, so this side here is opposite to the angle, and this side is adjacent to the angle 20. And similarly here, this side is adjacent to angle 18, and this side, represented by h, is opposite to angle 18. So next, we're going to write an expression for the triangle that's on the ground. And we're going to use the Pythagorean theorem for this expression. So since it's a right angle triangle, r squared plus p squared is going to equal 100 squared. So the two shorter sides squared added together is going to equal the hypotenuse squared. So the hypotenuse in this case is 100 meters. So now we have three unknowns. So we don't know the height, we don't know the value of r or the value of p. So what we're going to do is we're going to use substitution. So what I'm going to do is I'm going to try to substitute these expressions. So the expression for the triangle on the left and the expression for the triangle on the right into the Pythagorean theorem expression. So first I'm going to rearrange this expression. So I'm going to isolate for r. So r is going to equal h over tan 20 and p is going to equal h over tan 18. And what I'm going to do now is I'm going to substitute these expressions, so the expression for r and the expression for p, into this expression, into the Pythagorean theorem expression. So what we're going to get is we're going to get h over tan 20 squared plus h over tan 18 squared is going to equal 100 squared. So simplifying that further, we're going to get h squared over tan squared 20 plus h squared over tan squared 18 is equal to 100 squared. And now what I'm going to do is I'm going to factor out h squared, and I'm going to get 1 over tan squared 20 plus 1 over tan squared 18 and that's going to equal 100 squared. Simplifying this, I'm going to get 17.021 in the bracket, so equals 100 squared. And now I'm going to divide both sides by 17.021. And the last step is to square root that. So squared. And that's going to give me approximately, that would be, so rounded to one decimal, rounded to the nearest meter, that would be 24 meters. Okay? So what we can conclude is that the height of the balcony above the ground is 24 meters. Okay, so if you enjoyed this video, please give it a like, and also check out other videos on my channel that are similar to this one. Thank you for watching.